Yes, you can start. Huh?
Okay, so welcome all of you to this physics lecture.
Just a moment, just a moment. Okay, you can start.
Ma'am, voice is not audible.
Yes, I don't know whether he is explaining something. Parth, have you start explaining? Parth,
Okay, am I audible?
now you are audible.
Okay. So this is the lecture for superconductivity. I'm going to give some idea about superconductivity. Special thanks to our physics LDC department to give a chance to students to present a PPT. And this is my intro. I'm Parth Karia from computer department.
Parth, you are not audible.
Now I am audible.
Yes.
Okay. So we have studied in previous module that there are three types of solid states on the basics of electrical conductivity or we can say resistivity. That three types are first one is metal, second one is semiconductor, and the third one is non-metal, or we can say conductors, semiconductors, and insulators. So let's see something new about in physics. Okay. So here is the scientist whose name is H.K. Onsor. We know that there are lots of metals who are good conductors of electricity, and as they contains a tremendous number of electrons which are free at the low resistance offered by them to the flow of current is attributed to scattering of free electron by vibrating ions of lattice. So when the temperature increase, amplitude of lattice vibration will also increase, and just because of this, more scattering of electron leading to the more resistance. H.K. Onser was in 1911. Once upon a time, he was doing a practical with a low temperature with highly purified mercury, and at 4.15 Kelvin temperature, he found that mercury has a zero resistance. It means infinite conductivity. We know that from the we know that from V is equals to IR, H.K. Onser found that there is a zero resistance, so it means conductivity would be infinite. So can you imagine what happened after that? So this was the new phenomena in the physics which were found by the HK Onsers, and after that he named this phenomena as superconductivity. I'm going to try to define this new phenomena. Superconductivity, it is the phenomena in which electrical resistance of material suddenly disappears below a certain temperature, and the material that exhibits superconductivity and which are in superconducting states are also called superconductor. It means at below a certain temperature you found that that material has a very good conductivity, which is called after this found by H.K. Onser. It is called superconductivity. And which material exhibits this phenomena? Those materials called superconductors. And there is another phenomena is there, which is called transition temperature. It is nothing look very different from other temperature, but we are differ all the terms for a particular phenomena, so we can define very well. So this is the transition temperature, the temperature at which a material abruptly changes into a superconductor is called transition temperature, and it is also known as a critical temperature. In some books it is denoted by critical temperature, and in some books it is denoted by transition temperature, and in some books it is also denoted by transition critical temperature. So this is the temperature at below this material exhibits superconductivity. If you find such a type of MCQ that which is just a moment. Okay, so you find something like MCQ, so you may ask that at which temperature you will find superconductivity in a material. So there would be many options like this. So this is the definition of the transition temperature or critical temperature. Here it is. So we can say that the temperature which is below to the transition temperature, at that temperature we will find superconductivity in the material. So this would be the right option. Got it?
Yes.
Yes.
Okay. So, sir, HK Onser, after finding this phenomena, HK Onser trying to make a graph and compare the superconductor and metals by its electrical resistivity or versus temperature, and here it is that graph. Okay, so this is the graph of resistivity versus temperature of superconductor and normal metals. At a certain temperature, normal metals is increasing resistivity after increasing in temperature, and we can see here that below a certain temperature resistivity would be going to zero. It means conductivity would be going on very high level. So it is called superconductivity. I have some
Hello.
information. Hello.
Hello.
Am I audible?
Hello?
Yes, yes.
Yes, please
I have a
clearly.
doubt.
Yes, please.
At temperature Tc, the resistivity is very low and conductivity is very high. So, in previous MCQ, answer must be B, I think.
At this temperature, at TC we can't say that it is material would be starting to exhibit superconductivity. We cannot specifically say that is it superconductor or not, but we can 100% sure about T temperature, which is less than TC. At that temperature we can say the material will 100% superconductor. So as that concern, I will say option A would be true. Is it okay?
Okay.
Okay. I have some informations about superconductor for you. Since the discovery of superconductivity in metal, mercury, many metals have been found which are exhibiting superconducting at a very low temperature, like lead, then zinc, then all aluminum or other alloys are also there. So across 14 elements, pure elements, I am talking about pure elements, across 14 elements from the periodic table are found, are exhibiting superconductivity. Apart from this, there are thousand numbers of alloys which are showing superconductivity. So you may be study further that there are two types of superconductor. First one is which are made up from pure element, and the other one is made up from alloys, isn't it? Okay, so
Yes.
we were very thankful to that Dutch physicist that respected H.K. Onsor to give these wonderful gifts. This is superconductors, and he was awarded with the Nobel Award for the low temperature discovery in 1913. And this is from my side. Thank you to Vaishali ma'am, Jigneshwar, and Hiral ma'am. Thank you. If anyone has any doubt, let me know. I will try to explain.
Very nice, huh, Parth? Nicely explained. You have explained very nicely. Same way, even the Nirali, when Nirali has explained, she has also explained very nicely, Nirali. A main thing which even you have shown that we are having a different type of the superconductors, one that is prepared from the alloys as well as some of them which are prepared from the elements. So all you people do remember that when we have done a types of the superconductors, we had a type 1 and type 2 superconductors. આપણે જોયા type 1 and type 2 superconductors, soft and hard superconductors.
મેમ બાકી છે. મેમ એન ડિવિઝન માં બાકી છે.
n માં બાકી છે
ओ
તો કઈ નહીં
डिवीजन में ओ डिवीजन में बाकी है.
अच्छा यानी कंप्यूटर में बाकी होगा. So when we will go to see, when we will see this type of the superconductor, there is a one type which are the soft superconductor, another hard superconductor, जिसका critical magnetic field का value बहुत ही low होता है, those are the soft, and जिसका critical magnetic field का value बहुत high होता है, those are the hard. Generally pure elements fall in these soft superconductors. जो pure elements होते हैं जो सुपरकंडक्टिंग स्टेट में कन्वर्ट हो सकते हैं, उनका क्रिटिकल मैग्नेटिक फील्ड का वैल्यू बहुत कम होता है, पर जो अलॉयज है उसका क्रिटिकल मैग्नेटिक फील्ड का वैल्यू बहुत ही ज्यादा रहता है. एंड रिसर्च इज कंटिन्यूअसली गोइंग ऑन कि कौन सा क्या मिक्स करके हमें ऐसा सुपरकंडक्टर मिले कि जो बहुत ज्यादा हाई मैग्नेटिक फील्ड पे काम कर पाए, जिससे कि हम और ज्यादा एप्लीकेशंस में उसे यूज कर पाए, हाई मैग्नेटिक फील्ड के साथ उसे हम यूज कर पाए. ठीक है. And Parth has shown a PPT in which part PPT share कर सकते हो जो ग्राफ दिखाया था सिंपल नॉर्मल मटेरियल का और सुपरकंडक्टर का. उसमें हमने देखा था कि अगर सुपरकंडक्टिंग स्टेट में कन्वर्ट होता है तो उसका रेजिस्टेंस बिल्कुल जीरो आ जाता है. ठीक है. And if it is a normal, in a normal state, the normal state में वो ग्राफ धीरे धीरे से रिड्यूस होके आप देखोगे y एक्सिस पे रेजिस्टिविटी के एक्सिस पे कहीं पे टच कर रहा है. You may see it touches somewhere. It is not exactly zero. The blue color graph, is it visible? That blue color touches at some value of the resistivity even at a zero temperature. पार्थ अगर पॉइंटर है तो दिखाओ जहां पे ब्लू कलर टच कर रहा है और नीचे जीरो है, वो वाला पोर्शन आई एम टॉकिंग अबाउट. हाँ, वहां से ऊपर ब्लू लाइन जहां पे टच होता है ना वो वाला. हाँ, करेक्ट, दैट पोर्शन. So some value of the resistivity is still there even if the temperature is zero. Normal conductor में क्या हो गया, आप टेम्परेचर नीचे ले रहे हो, रेजिस्टेंस जीरो होगा, कम होगा. You are lowering down its temperature, its resistance will also lower down. But at some point, even if the temperature will become zero, there will be certain amount of the resistance there. वो ग्राफ पे हमें मिल रहा है. That amount of the resistivity, that resistivity is known as the residual resistivity that resides there even if whatever the amount of the temperature will be there. आप जीरो पे भी लेके आओ फिर भी कुछ vibrations तो atoms में, electrons में उसमें रहता ही रहता है, and they will provide some resistance. That's why that resistivity is known as a residual resistivity of the material. पार्ट पीपीटी भी बहुत बढ़िया बनाया हुआ है और बहुत अच्छी तरह से एक्सप्लेन किया. वेरी नाइसली डन, नाइस प्रेजेंटेशन. Thank you so much. Thank you, dear. Now